In this video, we're going to take a look at two more counting rules. And so for this first one, let's suppose we need to know the number of ways in which a subset of an entire group of items can be arranged in order. Each possible arrangement is called a permutation. Okay, so what are permutations? Well, permutations is, again, it counts the number of ways of arranging X objects selected from N objects in order. And this is, and our notation is N, lowercase n for the number of objects, capital P for permutations, lowercase x is the number of the subset, the amount of, the size of the subset of the number of objects n that we are selecting. And the total number of ways that we can arrange those X objects in order is n factorial divided by n minus x factorial. Let's think about this with the problem of 5 runners in a race, and we want to know how many options do we have for first place and second place in that order. As in, person A getting first place and person B getting second place is different than person B getting first and person A getting second. So how many number of ways can we order 2 people out of those 5 runners? Well, let's think in general about what's going on in this problem. Let's actually just write out what could happen. Well, first place can go to any of the 5 runners. And we're just going to call these people 1, 2, 3, 4, and 5. So first place could be any of those 5 runners. Well, if the first place person is runner 1, who could the second place be? Well, the second place could be 3, 4, or 5. The person 2, 3, 4, or 5. If the first place runner is runner number 2, then second place could have been runner 1, or 3, or 4, or 5, and so on. And again, what does this represent? This right here represents the first place was runner 3, and second place was runner 1, or here runner 2, or here runner 4, or here runner 5. And what are the total number of possibilities here? Well, this ends up being 5. And then for each of those 5, we had 4 selections for second place. So 5 times 4 equal to 20 here. Why does this make sense with this formula up here, though? Well, if we just think about what's the number of ways that all 5 people could have been ordered, that is 5 factorial. And then what do? Well, for each one of these selections here, we have 6 possibilities for who ends up in 3rd, 4th, and 5th, right? So if first person is first, second person is second, then from there on for 3rd, 4th, and 5th, we could have had 3rd person, 4th person, 5th person, or we could have had the 3rd person, then the 5th person, and then the 4th. That could have been the ordering. And then similarly, we could have had the 4th person get 3rd place. So 4, 5, 3, or 4, 3, 5. And then the same thing for if the 5th person was 3rd place. So this is 6 outcomes given 1 and then 2. As in, given that the first place was person 1 and second place was person 2. So again, for each of these options up here, we have 6 outcomes. Or in other words, 3 times 2 times 1. So 3 factorial. So what is actually happening here to calculate this 20? Well, we could take n factorial, right? N is 5 here. So we could take n factorial, which is 5 factorial here, and then we divide that by n minus, in our question we said that x was 2, so n minus x factorial. So our calculation could be 5 factorial, which is 120, over 3 factorial, which is 6. Or in other words, we get a total of 20. So we could have just, in this example here, we could have just counted that it was 20. The number of ways of arranging 2 objects from 5 objects, out of 5 objects, was 20. And we could have just counted that when our numbers are small enough. But we see through this example that this formula up here could have also calculated that value. So let's go ahead and work this out using a different example. So let's do example 4. Let's say that we're given 7 books. How many ways can we arrange 4 books on a shelf? Well, to do this, this is the number 7p4, as in the number of permutations choosing 4 objects out of 7 objects. How do we do that? That is 7 factorial over 7 minus 4 factorial, just plugging everything in. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 7 minus 4 is 3, so 3 factorial is 3 times 2 times 1. And notice here that this is really nice. 7 factorial divided by 3 factorial gives us a nice little calculation that 3 times 2 times 1 all cancels with the 3 times 2 times 1 up here. So this is really 7 times 6 times 5 times 4. 7 times 6 is 42. Times 5 is 210. Times 4 is 840. So we get 840 here as the number of different ways that we can arrange 4 books out of a total of 7 books. All right. Well, there is one more rule that we want to cover in this video, and that is combinations. So we had permutations before, and now we want to look at combinations. So now, if we are interested in a similar example, but we no longer care about order, then the number of combinations is nc sub x. So lowercase n, capital C, lowercase x. This is the number of combinations. It is a very similar formula. It is n factorial over x factorial times n minus x factorial. So the only difference from the previous thing is we're also dividing by an x factorial. And what does this do? This just tells us the number of combinations that we could pick. So in other words, in our previous example, so we could look at our previous example here. So given 7 books, how many ways can we select 4 books? We no longer care what order those books are selected in. We're not arranging them on a bookshelf, and so we don't care about the order that they are on the bookshelf. We just want to know, if we have 7 books, how many different selections of 4 books could we make? And that's what this formula right here can answer. So we get 7 books. So this is a formula called 4 choose 7. So one way we can write this out is with this notation. It is called the choose notation. In other words, how many ways can we choose 4 books out of 7 books? And this is 7 factorial over 4 factorial times 7 minus 4 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 4 times 3 times 2 times 1 times 3 times 2 times 1. Sorry, it was off the page. And so, well, 4 factorial can cancel with this 4 times 3 times 2 times 1. All right, 6 over 3 reduces to 2 over 1. And then the 2's cancel. So this is really just 7 times 5 here. Or in other words, 35 different ways to choose 4 books out of 7 books. So again, this formula is for combinations. It's called combinations. And that helps us choose X number of objects out of N objects. Or really it tells us the number of ways that we could select X objects out of N objects. All right, and that's where we'll conclude this video.